According to the National Electrical Code, specifically referencing Chapter 9, Article 90 of the 2020 edition, you cannot pass 0.75-inch PVC lines for outside air conditioners through an unfused gutter. All conductors passing through a gutter must be enclosed in a raceway and be protected by overcurrent devices. This means that the 0.75-inch PVC lines must be enclosed in a conduit and protected by a fuse or a circuit breaker. Consider the scenario where a 500 mcm cable is coming from the meter to the gutter, and the intention is to splice in the feeds for two 200 amp panels. Also present are two 0.75-inch PVC lines for outside air conditioners intended to pass through the same gutter. If the 500 mcm cable is fused with an #8 fuse, but the 0.75-inch PVC lines are not fused, this arrangement is non-compliant with the NEC. The appropriate way to address the situation, ensuring code compliance and safety, involves several crucial steps. Firstly, install a conduit from the meter to the gutter. The conduit size must adequately accommodate both the 500 mcm cable and the two 0.75-inch PVC lines. Secondly, ensure the conduit is protected by a fuse or circuit breaker of appropriate amperage. Once the conduit is correctly installed, splice in the feeds for the two 200 amp panels can proceed within the gutter. However, it is vital that the 500 mcm cable is protected by its own dedicated fuse or circuit breaker. Simultaneously, the two 0.75-inch PVC lines also require protection via their own respective fuses or circuit breakers. It's crucial to understand the underlying principles. Overcurrent protection is a fundamental concept in electrical safety. Overcurrent occurs when the current flowing through a conductor exceeds its safe ampacity rating. This can be caused by several factors including short circuits, ground faults, or overloads. Without overcurrent protection, excessive current can lead to overheating, insulation damage, fires, and potentially electrical shock hazards. Fuses and circuit breakers are the two primary types of overcurrent protection devices. A fuse contains a metal element designed to melt and break the circuit when the current exceeds a predetermined level. Fuses are single-use devices and must be replaced after they blow. A circuit breaker is a resettable device that trips open when it detects an overcurrent condition. Circuit breakers can be manually reset after the fault has been cleared. Gutters, also known as auxiliary gutters or wireways, are metal enclosures used to house and protect electrical conductors. They are typically used in situations where multiple conductors need to be routed together, such as between a meter and a panel board. Gutters provide a convenient and organized way to manage wiring and ensure that conductors are properly supported and protected from physical damage. However, gutters are not intended to be used as junction boxes. Conductors should only be spliced within a gutter if the splice is properly insulated and supported. Furthermore, the NEC has specific requirements regarding the fill capacity of gutters. The total cross-sectional area of all conductors within a gutter cannot exceed 20% of the gutter's internal cross-sectional area. This is to ensure adequate ventilation and prevent overheating. Now let's focus on the specifics of conductor types and sizes. The 500 mcm cable refers to a conductor with a cross-sectional area of 500,000 circular mils. MCM is an older unit of measure, now typically expressed as kc mil, but both refer to the same size. The ampacity of a 500 mcm cable depends on its insulation type and the ambient temperature. However, it is generally rated for several hundred amps. The #8 fuse mentioned in the original scenario appears to be undersized for a 500 mcm cable. A fuse or circuit breaker should be sized to protect the conductor from overcurrent without causing nuisance tripping. Consulting the appropriate NEC tables, such as Table 310.15b16, is essential for determining the correct ampacity for a given conductor size and insulation type. The 0.75-inch PVC lines likely refer to conduits containing the conductors for the outside air conditioning units. The size of the conductors within these conduits will depend on the load requirements of the air conditioning units. Typically, air conditioning units require dedicated circuits with appropriately sized conductors and overcurrent protection. The two 200 amp panels represent the main distribution points for the electrical system. Each panel has a 200 amp main breaker, which provides overcurrent protection for the entire panel. However, individual branch circuits within the panel must also be protected by their own circuit breakers or fuses. In summary, the NEC provides a comprehensive set of rules and regulations for electrical installations. These regulations are designed to ensure safety and prevent electrical hazards. When working with electrical systems, it is crucial to have a thorough understanding of the NEC and to follow all applicable codes and standards. Now let's elaborate on the NEC requirements related to gutters and waterways. Article 376 of the NEC covers the installation and use of metal waterways, and Article 378 covers non-metallic waterways. These articles provide specific guidelines on the construction, installation, and support of waterways. Some key requirements include: firstly, waterways must be securely supported. The NEC specifies the maximum spacing between supports, which depends on the type and size of the waterway. Secondly, waterways must be installed in a neat and workmanlike manner. This means that all connections and terminations must be properly made, and the wiring must be organized and secured. Thirdly, waterways must be accessible. This is to allow for inspection, maintenance, and modifications to the wiring system. Fourthly, waterways cannot be used in hazardous locations unless they are specifically listed for such use. Fifthly, the sum of the cross-sectional areas of all conductors at any cross-section of a waterway must not exceed 20% of the interior cross-sectional area of the waterway. Where directing factors are required, the number of conductors must be adjusted accordingly. Now let's look into the requirements for overcurrent protection. Article 240 of the NEC covers overcurrent protection. This article provides detailed requirements on the selection, installation, and location of overcurrent devices. Some key requirements include: firstly, overcurrent devices must be readily accessible. This is to allow for easy replacement or resetting of the device. Secondly, overcurrent devices must be protected from physical damage. This can be achieved by installing them in enclosures or using other protective measures. Thirdly, overcurrent devices must be properly rated for the circuit they are protecting. The ampere rating of the overcurrent device must not exceed the ampacity of the conductor it is protecting. Fourthly, overcurrent devices must be installed at the point where the conductors receive their supply. This is to ensure that the entire circuit is protected from overcurrent. Fifthly, fuses and circuit breakers must be of the correct type and size for the application. The NEC provides tables and guidelines for selecting the appropriate overcurrent device for various types of circuits and equipment. Furthermore, it is important to consider the interrupting rating of overcurrent devices. The interrupting rating is the maximum fault current that an overcurrent device can safely interrupt. Overcurrent devices must have an interrupting rating sufficient to handle the available fault current at their point of installation. In the scenario described, the 500 MCM cable is being fed from a meter. The meter itself is typically protected by an overcurrent device such as a main breaker or a set of fuses. However, the conductors between the meter and the gutter must also be protected. This can be achieved by installing an overcurrent device at the meter or at the point where the conductors enter the gutter. The size of the overcurrent device must be based on the ampacity of the 500 MCM cable. The #8 fuse mentioned in the original scenario is clearly undersized for a 500 MCM cable. A 500 MCM cable typically has an ampacity of several hundred amps, depending on its insulation type and the ambient temperature. Therefore, the overcurrent device protecting the 500 MCM cable should be rated accordingly. Regarding the two 0.75-inch PVC lines for the air conditioning units, each line must be protected by its own overcurrent device. The size of the overcurrent device must be based on the ampacity of the conductors within the PVC conduit. The conductors within the PVC conduit must be sized to carry the load of the air conditioning units, taking into account factors such as the motor's horsepower and the voltage of the circuit. The NEC provides tables and guidelines for determining the appropriate conductor size and overcurrent protection for air conditioning equipment. In addition to overcurrent protection, grounding is another essential aspect of electrical safety. Grounding provides a low impedance path for fault current to flow back to the source, which helps to trip the overcurrent device and clear the fault. The NEC provides detailed requirements for grounding electrical systems and equipment. All metal enclosures, such as gutters and panel boards, must be properly grounded. Conductors must also be grounded, typically through a grounding electrode system that includes ground rods, ground plates, or connections to the building's metal frame. Proper grounding helps to prevent electrical shock hazards and ensures the safe operation of electrical equipment. Now let's clarify some key terms and definitions. Ampacity is the current carrying capacity of a conductor. It is the maximum current that a conductor can carry continuously under specified conditions without exceeding its temperature rating. Overcurrent is any current in excess of the rated current of equipment or the ampacity of a conductor. Overcurrent can be caused by short circuits, ground faults, or overloads. Short circuit is an unintentional connection between two or more conductors of different potential. Short circuits result in a very high current flow, which can quickly damage equipment and cause fires. Ground fault is an unintentional connection between a conductor and ground. Ground faults can create a shock hazard if someone comes into contact with the energized equipment or ground. Overload is the operation of equipment in excess of its rated capacity. Overloads can cause overheating and damage to equipment. Raceway is an enclosed channel designed to hold wires, cables, or busbars. Raceways can be made of metal or non-metallic materials. Conduit is a type of raceway that is typically made of rigid metal or plastic. Conduit provides excellent protection for conductors and is often used in harsh environments. Wireway is a type of raceway that is typically made of metal and has hinged or removable covers. Wireways are often used to route and protect large numbers of conductors. In the scenario described, the use of PVC conduit is acceptable for the air conditioning circuits, as long as the conduit is properly installed and supported. However, the NEC does not allow conductors to be run through a gutter without being enclosed in a raceway. Therefore, the 0.75-inch PVC lines must be extended all the way to the panel board. Another important consideration is the labeling of electrical equipment. All electrical equipment, including panel boards, disconnect switches, and overcurrent devices, must be properly labeled. The label should indicate the voltage, current, and other important information about the equipment. This helps to ensure that electricians and other qualified personnel can safely work on the equipment. Furthermore, the NEC requires that all electrical work be performed by qualified personnel. Qualified personnel are those who have the necessary training and experience to safely install and maintain electrical systems. It is important to hire a licensed electrician for any electrical work to ensure that the work is done correctly and in accordance with the NEC. In addition to the NEC, there may be local codes and regulations that apply to electrical installations. It is important to check with the local authorities to determine if there are any additional requirements that must be met. Local codes may address issues such as permitting, inspections, and specific installation practices. Compliance with both the NEC and local codes is essential for ensuring the safety and reliability of electrical systems. In conclusion, the scenario described involves several violations of the NEC. The 0.75-inch PVC lines cannot be run through the gutter without being enclosed in a raceway. The 500 mcm cable must be protected by an overcurrent device of the correct size. All electrical work must be performed by qualified personnel and in accordance with the NEC and local codes. It's also important to consider arc flash hazards. Arc flash is a dangerous phenomenon that can occur when there is a fault in an electrical system. Arc flash events can generate intense heat and pressure, which can cause serious burns and other injuries. To mitigate arc flash hazards, it is important to follow safe work practices and to use appropriate personal protective equipment (PPE). PPE for arc flash protection can include flame-resistant clothing, gloves, face shield, and safety glasses. Furthermore, it is important to perform a hazard assessment before working on any electrical equipment. The hazard assessment should identify potential arc flash hazards and determine the appropriate level of PPE to use. The NEC includes requirements for arc flash hazard assessments and for the labeling of electrical equipment to warn of potential arc flash hazards. Another relevant aspect to consider is surge protection. Electrical surges can damage sensitive electronic equipment. Surges can be caused by lightning strikes, power grid switching, or other electrical disturbances. To protect electronic equipment from surges, it is recommended to install surge protective devices (SPD). SPD can be installed at the service entrance, at the panel board, or at individual equipment locations. The NEC includes requirements for the installation of SPD. The type and rating of the SPD should be selected based on the specific application and the level of surge protection required. Now let's delve deeper into the specifics of panel board installations. Panel boards are the heart of the electrical distribution system. They are used to distribute power from the service entrance to individual branch circuits. Panel boards must be properly installed and maintained to ensure safe and reliable operation. The NEC includes detailed requirements for panel board installations. Some key requirements include: firstly, panel boards must be located in readily accessible locations. This is to allow for easy access for maintenance and repairs. Secondly, panel boards must be protected from physical damage. This can be achieved by installing them in enclosures or by using other protective measures. Thirdly, panel boards must be properly grounded. This is to prevent electrical shock hazards. Fourthly, panel boards must be properly labeled. This is to identify the circuits and equipment that are served by the panel board. Fifthly, panel boards must be properly ventilated. This is to prevent overheating. The NEC also includes requirements for the wiring within panel boards. All conductors must be properly sized and insulated. All connections must be properly made and tightened. The panel board must be kept clean and free of debris. Overcrowding of conductors within the panel board should be avoided. Now let's discuss the importance of regular electrical inspections. Regular electrical inspections can help to identify potential problems before they become serious hazards. Electrical inspection should be performed by qualified personnel. The frequency of electrical inspection should be based on the type of equipment, the environment in which it is located, and the history of problems. During an electrical inspection, the inspector will check for things such as damaged wiring, loose connections, overloaded circuits, and improper grounding. The inspector will also check for compliance with the NEC and local codes. If any problems are found, the inspector will recommend corrective action. Addressing these problems promptly can help to prevent electrical fires, electrical shocks, and other electrical hazards. It is always advisable to consult with a qualified electrician to ensure that electrical installations meet all applicable codes and standards and that they are safe and reliable. Remember that this information is a general overview and specific situations may require additional considerations.